When you think about a crime scene, the evidence is almost never clean and simple. It's messy, it's a jumble of different substances, and figuring out that mess can literally make or break a case. So the real trick in forensic science isn't just finding the evidence, it's figuring out how to unmix it to get to the truth. So let's just imagine this for a second. You've got a single drop of blood. That's it. But hidden inside that tiny drop could be a suspect's DNA, maybe trace amounts of a poison, or some kind of drug. The question is, how in the world do you pull that one critical piece out from everything else? Well, that's exactly the puzzle we're going to solve today. And trust me, it's not just about blood. Forensic scientists are up against all kinds of crazy mixtures. We're talking about isolating a single strand of DNA for a profile, or detecting a poison that's there in just tiny, tiny amounts. Or maybe finding microscopic gunshot residue on a shirt, or even figuring out what kind of accelerant was used to start a fire. Every single one of these is a separation problem at its core. So, how do they actually do it? Well, let's start with one of their biggest tools, a technique that uses the pure physics of spinning to sort things out. It's called centrifugation. The idea here is actually beautiful in its simplicity. Centrifugation is really all about spinning a sample at incredibly high speeds. This creates a really powerful centrifugal force that shoves the denser particles outward, away from the center. It's kind of like when you're on a fast-spinning carnival ride and you feel yourself getting pushed to the outside. Same exact principle. And this is what you get after that super fast spin. The heavier stuff, like cells or solid bits, gets packed down at the very bottom of the tube. We call that the pellet. And the lighter liquid that's left floating on top, that's the supernatant. And just like that, you've separated your mixture, based on nothing more than density. Pretty cool, right? Okay, but what happens when density isn't enough? What if the things you're trying to separate weigh about the same? For that, scientists switch gears from physics to chemistry with a technique called solvent extraction. Solvent extraction plays by a totally different rule, solubility. You know how oil and water just refuse to mix? That's because they're immiscible. This technique uses that exact property. It all comes down to the old chemistry rule of like dissolves like. You basically introduce a solvent that your target molecule finds more attractive than the liquid it's currently in, and that molecule will literally jump ship, dissolving into the new solvent and leaving the old mixture behind. The whole process is really straightforward. First, you mix your sample with a very carefully chosen solvent, then you give it a really good shake. This is what gives your target molecule the chance to move over into the new solvent. And because the liquids don't mix, they'll just naturally settle into two separate layers again. All you have to do is collect the layer that now holds your clue. All right, so we've got our two main tools in our forensic toolkit, centrifugation and solvent extraction. Now, let's put them to the test. Let's tackle our own little forensic case right here. Here is our evidence, a test tube with a messy mix of sand, oil, and some colored water. Our mission, should we choose to accept it, is to come up with a plan to perfectly separate every single one of these components. Okay, so where do we even begin? We've got a solid mixed in with two liquids. Let's think back to the tools we just talked about. Which one is the go-to for separating things like a solid from a liquid? Yep, you got it. Centrifugation. That dense, solid sand is the perfect candidate for this method. We give it a quick, high-speed spin, and all that sand is going to get forced to the bottom, forming a nice, solid pellet. That leaves the oil and water mixture on top as the supernatant. Step 1 done. Okay, the sand is out of the picture. Awesome. But now we're left with oil and colored water. They're not mixed, but they're still in the same container. So how do we actually get them into separate jars? This is where a key tool in solvent extraction comes in handy, a separating funnel. It's actually a pretty simple idea. Since oil and water are immiscible, they're going to naturally form two distinct layers. We can just carefully open a valve at the bottom and drain out the water layer, leaving the oil behind. It's a really simple, elegant separation that relies purely on their chemical properties. And there we go. That's our complete plan. First, we hit it with centrifugation to pull out the sand. Then we use a separating funnel to divide the oil and water. Each piece of our original mystery mixture is now totally isolated and ready to be analyzed. Case solved. Now, this little exercise might seem like a basic chemistry experiment, but I want you to remember that these are the exact same principles used in high-stakes criminal investigations, the kind that have a very real impact on people's lives. Out in the real world, these techniques are absolutely essential. Centrifugation is used every day to isolate DNA from blood cells. Solvent extraction is the key to pulling tiny amounts of drugs out of a urine sample, or finding traces of an accelerant in the debris from a suspicious fire. These aren't just little lab tricks. They are the absolute foundation of modern forensic science. And when the stakes are this high, accuracy is everything. I mean, these separation techniques are designed to be incredibly sensitive and specific, often hitting over 99% accuracy. Because when you're presenting evidence in a courtroom, there is just no room for error. It really makes you wonder, doesn't it? With tools this powerful, tools that can unmix almost anything, from a single drop of blood to a speck of dust, what other secrets are just sitting there, waiting inside a mixture, ready to be separated and finally revealed?